Hello students, in this video we will learn trigonometry part 2. In the previous chapter we have studied trigonometry function in the different quadrant. So in this chapter trigonometry part 2 we will learn trigonometry function of sum and difference of the angle, allied angle, multiple angles, factorization formulae and angle of the triangles. So let's see these all concepts one by one. The first concept, which is compound angle. Let's see what is the meaning of compound angle. The compound angles are sum or difference of the given angles, like a plus b or a minus b. So see, for any two angles a and b, cos of a plus b equal to cos A into cos B minus sin A into sin B. Let's see how we can prove this statement. Let us consider the unit circle. Draw a unit standard circle. Let's take a point P and Q on the circle. Here we will take point P and point Q on this unit circle. Angle A with standard position positive x-axis. Here OP makes an angle. This is the angle OP with positive x-axis, and OQ makes angle B with the positive x-axis. So here XOP, this is the angle A, and XOQ, this is the angle B. Once we know the angle, we can find the coordinates of the point P and point Q. As we have learned in previous chapter, if this is the distance, that is the radius is 1, and if this is the angle theta, then we know the coordinates which are cos theta comma sin theta. Similarly, this point also, the coordinates are cos theta comma sin theta. But here, what is the angle given? The angle XOP is A and the angle XOQ is B. So we can say the point P, here angle is A, so the coordinate of point P, it should be cos A comma sin A. Similarly, here angle XOQ is B, so the coordinate of Q, it must be cos B comma sin B. Once we get the coordinate of P and coordinate of Q, then easily we can find the distance between P and Q using the distance formula. What is the distance formula to find the distance? That is, distance PQ is equal to in square root y2 minus y1 bracket square plus x2 minus x1 bracket square. So what is x1 and y1 here? Cos A comma sin A, which is x1 y1, and what is x2 y2? Cos B comma sin B. So using this distance formula, let's find distance. So here PQ is equal to cos A minus cos B bracket square plus sin A minus sin B bracket square. Now we can expand this cos A minus cos B bracket square and sin A minus sin B bracket square using the formula. What is the expansion for A minus B bracket square? Which is A square minus 2AB plus B square. So using this formula, we can write this as cos square A minus 2 times cos A into cos B plus cos square B. Similarly, here sin A minus sin B bracket square can be written as sin square A minus 2 sin A sin B plus sin square B. Here we will rearrange these terms as we can combine cos square A plus sine square A in one bracket, as well as cos square B plus sine square B, it is in another bracket, and from these two middle terms, minus 2 cos A cos B and minus 2 sin A sin B, we can take minus 2 common and we can write cos A cos B plus sin A sin B. Here we know about the fundamental identity, which gives cos square A plus sin square A equal to 1. Similarly, cos square B plus sin square B, which is also 1, minus 2 times this cos A into cos B plus sin A into sin B as it is. So here 1 plus 1, which is 2, minus 2 times cos A cos B plus sin A sin B. And if I take the squaring on both sides, then we get the square of distance PQ, which is equal to 2 minus 2 into cos A plus cos B plus sin A into sin B. So let's call it as equation number 1. So in the same figure, here for this PQ, if we consider this ray OQ as again some new x-axis, then this will be new x-axis, and let's take some point R in between P and Q. So here if we consider OQ as a new x-axis, draw a new y perpendicular to it. So here this is OQ, which is new x-axis, and we are drawing the perpendicular, that is y-axis. Now here angle QOP, this angle QOP, because now this is new x-axis, that is why this angle should be what? As we know, the total angle is A and this angle is B. So obviously the difference between these two, it must be A minus B. Now here OQ is the new x-axis and this angle between QOP, which is A minus B. So using the coordinate, we can find the coordinate of point P, which are cos of the given angle, which is A minus B, comma sine of A minus B, like cos theta, comma sine theta. So here theta is what? A minus B. And as we have considered this OQ on the x-axis, so the coordinate of Q, it should be 1, 0, because it's a unit circle. So this distance OQ is 1. Now again, here we get the coordinate of P and coordinate of Q. So using these two coordinates, again we can find the distance between P and Q. Here x1, x2, which are cos of A minus B, sine of A minus B, and x2, y2, which are 1, 0. So let's find the distance between P and Q. So again, here distance is cos of A minus B minus 1 bracket square plus sine of A minus B minus 0 bracket square. Let us expand this using the formula like A minus B bracket square. So here first term square, that is cos square of A minus B minus 2 into first term into second term, which is 2 cos of A minus B plus second term square, which is 1 square, plus here sine of A minus B minus 0 is itself and its square, which is sine square of A minus B. Now like previous example, we can combine this cos square of A minus B and sine square of A minus B in a bracket plus 1 as it is, and this minus 2 cos of A minus B as it is. Now as we know, cos square of A minus B plus sine square of A minus B, we can write 1, and the remaining term 1 minus 2 times cos of A minus B as it is. So again 1 plus 1, which will give 2 minus 2 times cos of A minus B. So again if we take the squaring on both sides, we get distance of PQ square, that is equal to 2 minus 2 cos of A minus B. So let's observe the equation number 1, which is also same as distance PQ square, which is equal to 2 minus 2 times cos A cos B minus plus sin A sin B. Now by equating the equation number 1 and 2, we get that distance PQ square, which is 2 minus 2 times cos of A minus B, equal to 2 minus 2 times cos A cos B plus sin A sin B. So here 2 will be cancelled from both sides. Then we get minus 2 cos A cos B equal to minus 2 times cos A cos B plus sin A sin B. So again we can cancel minus 2 from both sides. So we get the identity, which is cos of A minus B is equal to cos of A plus B, cos A cos B plus sin A sin B. Now see the next theorem. For any angle A and B, cos of A plus B is equal to cos A cos B minus sin A sin B. So to prove this statement, we can use the previous one, which we know that cos of x minus y, which is equal to cos x cos y plus sin x sin y. Now here we will suppose this A as a x, that is x equal to A, and this minus y as a minus b. Then we can write this expression cos of A plus B as cos A cos B plus is equal to cos A cos B plus sin A and sin of minus b. Here we can write this y as minus b, that is cos of minus b, and we know that cos of minus theta is cos theta, so cos of minus b will be cos b, and here sin y we can write sin of minus b, and here sin of minus b is minus sin b, so we can write this as a sin b. So finally we get cos of A plus B, which is equal to cos A cos B minus sin A sin B. So here we get two identities, that is cos of A minus B is equal to cos A cos B plus sin A sin B, and cos of A minus B is equal to cos A cos B minus sin A sin B. So that means we get two formulas for sum of the angle as well as difference of angle for cos trigonometric function. So here we have to remember this. Whenever we have to find cos of sum, that is cos of A plus B, which is always difference of cos A cos B and sin A sin B, and cos of A minus B, which is sum of cos A cos B and sin A sin B. So simply cos of A plus B is cos cos minus sin sin, and cos of A minus B, which is cos cos plus sin sin. Let's see some result using this theorems. So cos of pi by 2 minus theta, which is always equal to sin theta. Let's see how we can prove this statement. As we know the identity about cos of difference of angle, that is cos of x minus y, which is equal to cos x cos y plus sin x sin y. If we compare this cos of x minus y with cos of pi by 2 minus theta, then we can say x is pi by 2 and y is theta. Let's put x is equal to pi by 2 and y equal to theta here. Then what we get? Cos of pi by 2 minus theta, which is equal to, say this is cos x cos y plus sin x and sin y. So what is x here? Pi by 2, and what is y here? Theta. That is cos of pi by 2 minus theta can be written as cos pi by 2 cos theta plus sin pi by 2 sin theta. Now we know about the value of cos of pi by 2 and sin of pi by 2. Let's put the value. Cos of pi by 2 means 90 degree. So cos 90 degree, which is 0, cos theta as it is, plus sin pi by 2, that is sin 90 degree, which is 1 into sin theta. So here 0 into cos theta, it will be 0 plus 1 into sin theta, which is sin theta. So here we get the identity, that is cos of pi by 2 minus theta, which is equal to sin theta. So here this is plus sin theta. So here make the correction. This is positive sine theta. Similarly, we can prove the following statement, that is cos of pi by 2 plus theta, which is equal to minus sine theta, sine of pi by 2 minus theta, which is equal to cos theta, and sine of pi by 2 plus theta, which is equal to cos theta. So these all results we can prove using the same formula, that is cos of x plus y as well as cos of x minus y. So simply how we have to remember these identities? Say cos of 90 minus theta, which is sine theta, and sine of 90 minus theta, which is cos theta. And for 90 plus theta, here sine of 90 plus theta is cos theta, and cos of 90 plus theta, which is minus sine theta. So here how we can remember these symbols? As we know 90 plus theta, that means this angle is more than 90 degree, which belong to second quadrant, and in second quadrant we know that sine theta is only positive. So here given function is cos, and cos is negative in the first quadrant, so we are taking negative symbol here. And here sine of 90 plus theta, this angle is also belong to the second quadrant, and in second quadrant sine is positive, so we are taking the positive. See some more formulas, that is tan of pi by 2 minus theta, it can be written as sine of pi by 2 minus theta upon cos of pi by 2 minus theta. As we know sine of pi by 2 minus theta, which is cos theta, and cos of pi by 2 minus theta, sine theta. So here it cos upon sine, which is cot theta. So we get that identity tan of pi by 2 minus theta, which is cot theta. Similarly, tan of pi by 2 plus theta, which will be minus cot theta. So here pi by 2 plus theta, which is the angle belong to the second quadrant, and in second quadrant tan is negative, so we take negative. For angle pi by 2 minus theta, this angle is always less than 90 degree, that means it is belong to the first quadrant, and when angle belong to the first quadrant, all the trigonometric functions are positive. That's why there is no need to write the symbol, that is they are always positive. So simply here we can remember this formula, that is sine of 90 minus theta is cos of 90 minus theta is sine theta, sine of 90 minus theta is cos theta, tan of 90 minus theta is cot theta, similarly cot of 90 minus theta is tan theta. But when it is 90 plus theta, then that means it is belong to the second quadrant, and in second quadrant only sine is positive, that is why sine of 90 plus theta is positive cos theta, and for remaining all we have to take the negative symbol, that is cos of 90 plus theta, which minus sine theta. Similarly tan of 90 plus theta, which is minus cot theta. Let's see the similar identities about sine, that is sum or difference of sine angle. See, for any two angles A and B, sine of A minus B, which is equal to sine A cos B minus cos A sine B. That is, difference of sine angle can be written as sine A cos B minus cos A sine B. So to prove this identity, we can use the theorem, that is cos of pi by 2 minus theta, which is sine theta. So here we will suppose that this angle theta as say A minus B, then we can write this cos of pi by 2 minus A minus B, which is same as sine of A minus B. That means we can write sine of A minus B equal to cos of pi by 2 minus A minus C. See here, this A minus B is theta, and we know sine theta is same as cos of pi by 2 minus theta, and we replace theta by A minus B. Now here if we simplify this bracket, we can write pi by 2 minus A, and minus minus become plus B. Now Again we will use the formula. Say this is some angle x and this is some angle y. So here we have to expand cos of a x plus y. As we know the formula for cos of x plus y, which is cos x cos y minus sin x sin y. What is x here? X is pi by 2 minus a. What is y here? B. Similarly, sin x sin y. What is x here? Pi by 2 minus a. So we can write cos of pi by 2 minus a. This is first angle plus some second angle b can be written as cos x cos y minus sin x sin y. That is cos of pi by 2 minus a cos b minus sin of pi by 2 minus a into sin b. So here cos of pi by 2 minus a, which is sin a cos b as it is, sin of pi by 2 minus a, which is cos a sin b as it is, because we know the property, that is cos of 90 minus theta, that is pi by 2 minus theta, is sin theta, and sin of pi by 2 minus theta, which is cos theta. So we get here sin of a minus b, which is equal to sin a cos b minus cos a sin b. So similarly we can prove for any two angles a and b, sin of a plus b, which is equal to sin a cos b plus cos a sin b. This theorem also we can prove using the previous theorems. So like cos of pi by 2 minus theta, that is equal to sin theta. Using this identity, even we can prove this. So here we have to remember the difference or sum of sine function is in the form, that is sin of a minus b is sin a cos b minus cos a sin b, and sin of a plus b, which is sin a cos b plus cos a sin b. That is for compound angle of sines, the terms are like sin cos, cos sin. For negative, we have to take negative. For positive, we have to take positive. And for cos, we know cos of a plus b is cos cos minus sin sin. And cos of a minus b, which is cos cos plus sin sin. Let's see the next theorem. For any two angles, capital A and B, tan of a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. So here we have to show that tan of a plus b is same as this tan a plus tan b upon 1 minus tan a tan b. To prove this identity, let's consider the LHS. So LHS, which is tan of a plus b, as we can write tan theta as sin theta upon cos theta. So here angle theta is a plus b. That means we can write tan of a plus b as sin a plus b upon cos a plus b. So here we can expand the sin of a plus b as sin a cos b plus cos a sin b. Similarly, we can expand cos of a plus b as cos a cos b minus sin a sin b. After expanding the numerator and denominator, we will divide this numerator and denominator by cos a cos b to numerator and denominator. Once we divide by cos a cos b, this cos a cos b will divide to the first term as well as it will be divided to the second term. Similarly, in denominator, this cos a cos b will be divided to the first term as well as it will be divided to the second term. So here we get sin a cos b divided by cos a cos b plus cos a sin b upon cos a cos b whole divided by, so this denominator will be divided to the both term, that is cos a cos b upon cos a cos b minus sin a sin b upon cos a cos b. Now if we observe here, the term cos a cos b will be cancelled and remaining term is sin a upon cos a, which is tan a. Similarly here cos a cos b will be cancelled, that is sin b upon cos b, which is tan b. Here the both term cos a cos b cancel, cos a cos a cancel, cos b cancel, which is 1, and sin a upon cos a, which is tan a, into sin b upon cos b, which is tan b. So by expanding this, we get that sin A upon cos A, which is tan A, sin B upon cos B, which is tan B, 1 minus sin A upon cos A, which is tan A, sin B upon cos B, which is tan B. So we get the result, that is tan of A plus B equal to tan A plus tan B upon 1 minus tan A tan B. So similarly, we can prove for any two angles A and B, tan of A minus B, which is equal to tan A minus tan B upon 1 plus tan A into tan B. So remember this, how we can simplify tan of A plus B as tan A plus tan B upon 1 minus tan A tan B, and tan of A minus B as tan A minus tan B upon 1 plus tan A tan B. These results are very important. We have to use this result to solve the example. Now, if none of the angle A and B and A plus B is multiple of pi, then we can write cot of A plus B as cot A cot B minus 1 upon cot B plus cot A. Similarly, cot of A minus B as cot A into cot B plus 1 upon cot A minus cot B minus cot A. See here, like the formulas, tan of A plus B, which is tan A plus tan B upon 1 minus tan A tan B, and tan of A minus B, which is tan A minus tan B upon 1 plus tan A tan B. We can write the formulas for cot of A plus B and cot of A minus B. The formula for cot of A plus B, which is cot A into cot B minus 1 upon cot A plus cot B plus cot A. Similarly, cot of A minus B, which is equal to cot A into cot B plus 1 upon cot B minus cot A. So, in today's lecture, we have learned the identities, that is cos of A plus B, which is cos A cos B minus sin A sin B, cos of A minus B, which is cos A cos B plus sin A sin B. So remember, the expansion of cos contain term cos cos minus sin sin, as well as cos of A minus B, which is cos cos plus sin sin. So for cos, when it is plus, we have to take minus, and when minus, we have to take plus. The next identity, which is sin of A plus B, which is sin A cos B plus cos A sin B, and sin of A minus B, which is sin A cos B minus cos A sin B. So remember, the expansion of sin contain term sin cos cos sin. For plus, we have to take plus, and for minus, we have to take minus. Tan of A plus B, which is tan A plus tan B upon 1 minus tan A into tan B. So, in the expansion of tan, we have to write it is tan A plus tan B upon 1 minus tan A tan B. So, when here it is plus, we have to take plus at numerator, minus at denominator. Similarly, tan of A minus B, which is tan A tan B upon 1 minus tan A tan B. When here it is minus, we have to take minus, and at denominator we have to take plus. And cot of A plus B, which is equal to cot A cot B minus 1 upon cot B plus cot A. Similarly, cot of A minus B, which is cot A cot B plus 1 upon cot B minus cot A. So, for the expansion of cot, we have to write cot A cot B minus 1 upon cot B plus cot A. Similarly, for minus, we have to take numerator plus and denominator minus. And the next allied angle formulas, which are sine of 90 minus theta cos theta, cos of 90 minus theta sin theta, tan of 90 minus theta cot theta, and cot of 90 minus theta tan theta. That means whenever the compound angle 90 minus theta is given, then the function will be changed. Sine changed by cos, cos changed by sine, tan changed by cot, cot changed by tan. Similarly, we can change sec by cosec, cosec by sec. So here the all angles are 90 minus theta, that means they are less than 90. So all are belong to the first quadrant. That's why we are interchanging the trigonometric functions, but we are keeping all are positive because in first quadrant all trigonometric functions are positive. Let's see the identities about 90 plus theta. So sine of 90 plus theta, which is cos theta, cos of 90 plus theta, which is minus sine theta, tan of 90 plus theta, which is minus cot theta, and cot of 90 plus theta, which is minus tan theta. So similarly, whenever there is 90 plus theta, we have to write the same, that is the trigonometric function changes sine by cos, cos by sine, tan by cot, cot by tan. But we know these angles are 90 plus, that means they are more than 90 degree. That means all are belong to the second quadrant, and in second quadrant only sine function is positive. That's why we are taking this as positive term, and remaining all functions are negative in second quadrant. That's why we are taking here negative. So simply we have to remember, whenever 90 minus theta or 90 plus theta, then we have to change the function sine by cos, cos by sine, tan by cot, cot by tan, sec by cosec, cosec by sec. And for 90 minus theta, all are positive, but for 90 plus theta, only sine is positive and remaining all functions are negative. So in this way, we can remember this all formulas and we can solve the example based on these formulas. In next lecture, we will see the all example based on these formulas.